Hello, and welcome to a demo of Stage Precision Grid's new camera calibration system. We're going to start off with a new blank project. We're going to go ahead and add a camera. Then we're going to add 3D, which is how we'll be getting our tracking data in this case. We'll go ahead and set it to 6301 as that's the local port in my stage. We'll also go ahead and pick the camera tracking network and disable the output as we will not be using that. Next, we're going to go ahead and add our media input. In our stage, the device is an Aja, so we're going to grab the Aja Corvid channel 1, and you can see we've got 1080p 30 coming in, which means the signal is good. You'll want to make sure that your Use as Image Provider is toggled on. Next, we're going to go ahead and add some multi-calibration boards. So we want the multi-screen option here. We're going to go ahead and label this one wall, as our volume has a wall and a floor. We're going to go ahead and set the resolution here. My wall is a 3:1 aspect ratio, and since I know the height off the top of my head, I'm just going to multiply that by 3. Then we're going to set the height. All right, next we're going to go ahead and use the surface generator. You can get to this by right-clicking on the object itself. We're going to set the column's resolution to the width of the tile, which will be 176, and the full height of the column, which is 1584. So since these are row BP2V2, that's a ½ meter by 4.5 meters. And then in our stage, we have 27 columns. So now Stage Precision will just go ahead and generate that mesh for me. Next, I'm going to go ahead and pick my middle surface, which is how I'm actually generating my 0 point, and tell Stage Precision I want this to be the center of the world. I'm going to label it center for my eyes and then put it up by half the height so that it is actually at 0, 0. The rest of the walls will adjust when we do our calibration. Next, I'm going to go ahead and create a map input on our camera and grab 3D, which is our focus value. You can see our raw focus right now is higher than the max focus range, so we're going to go ahead and rearrange it. I like to go up and down 3 times just to make sure that I hit both ends of this. Once you've seen both sides of it, you can just hit enter and it will go ahead and take. And now you can see our focus range has been adjusted to match the actual data we're getting. Now we're going to go ahead and create the size of our SP pattern for this wall. So we're going to do 0.25 just because these are ½ meter panels. I want to make sure that this is all good. It looks like it is, so we're going to go ahead and let it do that, but we're going to switch it to shuffle, which will make sure that we don't have any overlap when we add our floor later. Okay, next we're going to go ahead and add our floor calibration multi-screen. Similar to the wall, I'm going to label this just so I know which one is which. The resolution of this is 1280 by 896. And this is row BM4. So I'm going to go ahead and do our surface generator. We're similarly doing columns here. The resolution will be 128 by 896. For the dimensions of these tiles, they're actually 2 feet by 20 feet for the column. And I've went ahead and converted that to meters, so that's 0.609 by 4.267. Now we have 10 columns, and you'll go ahead and see that that's been generated by Stage Precision as well. So we are just going to go ahead and flip it by 90 here, just so I have an easier time seeing it. Stage Precision will go ahead and reposition that during our calibration though. We're also going to set this to 0.25 so that the scale of the marker is the same everywhere, and we're going to set that to shuffle. Next, I'm going to go ahead and export the images on these screens to take them to the wall and floor. In my case, I'm going to go ahead and save them as PNGs and bring them into Disguise. So as you can see here, you just go ahead and select where you want these to go. I'm going to version mine up to V4. As you can see, I have a V3 and for both of these. So I'm going to make sure that this wall goes to screen V4, and the floor will similarly go to screen V4. Now I'm just going to go ahead and check to make sure I saved the right one as the right one before I sync them over. So that is indeed the floor. And that is indeed the wall. So great. Next, I'm going to go ahead and move these over to Disguise, and then we'll be right back. Cool. So now that these are in Disguise, or your image processor, or media server of choice, we can go ahead and start with our calibration process. We're going to add a calibration object. We're going to go ahead and load a calibration. In this case, we're doing a lens and tracking calibration. We're going to go ahead and pick our media input as our image provider. We're going to select both of our walls. And here's where that center screen that we made earlier comes in handy. So we're going to click wall and then center. The master screen here lets stage precision know which screen shouldn't be moved. So everything else will be moved in relation to that screen. Okay, next we're going to grab the 3D input from the camera so we know what focus we're at. Now we are going to enable connected screens. This is a new feature in Stage Precision Grid that will align the vertices and actually combine them among your wall mesh. And it will help you skip that step of post-processing where you have to combine the vertices. Right, let's go ahead and open the new capture window. So in here you can see we have a calibrate toggle, you can see the image coming in, and you can see our data as it comes in. We also have other data down here that will tell us more as we capture images. So let's go ahead and move the camera. Ideally, you would like to start far out and take data as it comes in, and you'll see as I move this camera around that calibrations are starting to be captured and position themselves. You're able to just continually move this. There's no need to stop. Although you do want to get your camera settings set correctly before this. In this case, you want to go ahead and iris down as much as possible and up your ISO so that everything is visible. Great, so you can see that the grid has just snapped mostly into place. And something nice about this new version of the calibration is it will show you when certain mesh surfaces do not have enough data. So you can see everything in gray has enough data to know its position, but the stuff in red does not yet. So we're going to go ahead and focus on those areas. As we focus on those, you can go ahead and see under the solve status that we have 7 captures. It's telling us our current reprojection error and our sensor coverage. And you can see as more calibrations click in, they do change. We're happy about everything right now except for our screen angle. So we're going to try to do something a little better there. But the panels are happy, sensor coverage is happy. And just to see where we are in the process, we can go ahead and change these 2 calibration walls to be the inverse of their color so it's easier to tell when we are aligned. And we're going to go ahead and change on this to be the solve engine. So you can see these are pretty closely aligned. We're not temporally aligned into stage precision at the moment, but as these get together, you can see how nicely they overlay. Great. So let's go ahead and change our focus so we can take some new points. And you can see now as more of these calibrations have clicked in that the screen angle has gone green. Cool, so now that I've moved this focus, the solve status has gone away as we start taking new pictures. You can also see that our distortion has changed in our viewer there. So I'm going to move it back and grab wide angles again, get something at the top, get something near the bottom, just kind of float around and let stage precision capture images for me. Ideally, you want to try to get the extremities of your space and the tracking volume so stage precision knows about those different areas. Okay, so now we have data. You can see our reprojection error is a little high, but we do have good sensor coverage and the panels are in a good spot. So we're just going to go ahead and keep taking images and let stage precision refine this calibration for us. Now that reprojection error is in pixels, and ideally you'd have it sub 1. You can also see on our zoom focus steps that this step is yellow. That won't turn green until all of these different variables are green themselves. You can also notice that these cameras are the actual calibration points and their color reflects the data. Stage precision will automatically throw out all of the red ones and only use the yellow if it must. Green is good, as one can guess. You can see here as we advance, we've got more captures, but our reprojection error has gone up and the screen angle still isn't quite good yet. So we're going to keep taking some images here. While we calibrate, another reminder on how we should have the camera set up. Before you go into a calibration process, you should make sure that your ranges are set correctly, that your iris is as closed as possible, and that you have set your ISO so that everything is visible. We want that iris closed down so that as much of the screen is in focus as is possible. Okay, so let's look at this in more detail. And you can see as more calibrations happen, which you can tell are happening by the numbers at the bottom, it changes a little bit. So stage precision is still refining even as we're here, and it's starting to get happy with our reprojection error. For this demonstration, I'm going to go ahead and let it sit down and think about the rest of the calibrations it has while we move on to the other parts. As you can see in the GUI, as we talked about earlier, we have all of these different calibration representations in our visualizer. All the red ones are data that's being thrown out, and you can see new calibrations pop in as stage precision refines. You can see as stage precision calibrates, this gets better and better. I'm going to go ahead and lock this off here, and we'll come back to talk about the new lens profiles after stage precision is done calibrating this point. Okay, we're done with that, so we're going to go ahead and disable the calibration so it doesn't keep taking images while we do other things. You can see these numbers have stopped moving, which means we're good. So we're going to go ahead and save out our align profile, and then we're also going to go ahead and add our new Lens Pro profile. This is slightly different than the original one, as you can see by our fun new GUI here. You can still generate the traditional lens profile out of this, but this tends to be more accurate and gives you more control. So you can see we have a 3D representation and graph of how the interpolation will happen between all of our measured points for zoom, focus, center X, center Y, K1, K2, and lens offset. You can add to these by holding Alt and clicking. In this case, we're going to go ahead and add a point over here. Then we're going to go ahead and set it to something that makes sense. But you can see as I raise this, it changes the interpolation of the points around it. So I'm going to set that to zoom 0 since we're on a prime, and let's say 55 because we have a point at 50. And now you can see as I change the value of this, it changes the rest of the grid around it. But we're going to go ahead and delete this because I want to just use the data that we have from stage precision that it observed. This is how you would manually update a lens calibration if, for instance, you weren't able to get points at your far focus. So on the camera, we're going to go over to profiles. We're going to grab that Lens Pro profile. I forgot to add the add-on. So we're going to go ahead and enable that add-on real quick. Under the key, we need the camera calibration and lens alignment profiles. And now we can add that lens profile and the alignment profile. Just like before, we can go ahead and look at it through the distortion viewer to make sure that everything is lining up. So we're going to use our media input as the background, and we're going to change the alpha just so we can see things a bit better. In this current pre-release version, the export isn't perfect, so it will look better in the calibration, but that will be fixed before this is released. I'm going to go ahead and change the focus a bit. As you can see, everything is working. Okay, now that we've calibrated the walls and the lenses, let's go ahead and export our mesh as an OBJ. I'm going to use this to show off that connected mesh feature so that you can see all of our vertices are connected. We're going to go ahead and open Blender and delete all these objects before we import our mesh. So let's go ahead and click on Import, OBJ or Wavefront, go into Downloads where I saved the wall mesh, then we'll import it and tab into Object Mode so you can see the perfect vertices here. Now as I pick that option, you can see there is not extra vertices because they have been combined. I hope you've enjoyed this short demo of the Grid V2 calibration process.